Okay, so we're going to do one horizontal question, then we're going to move to our last one, which is vertical. But it's the same concept. Okay. So if we see a problem like this, we don't know the math. So what? Oh yeah, go for it. But Keegan. I got
the
one
good
over
one's over there.
That one's way better.
That one is louder though.
It is loud.
What's the problem?
No, you're good. Like, is it sharpened though?
Yeah, it's sharpened.
Next time.
All right,
Next time.
That one's the Dodge
All right. So here we go. Horizontal. What do we know? All right, we know the force constant, 120. We know the frequency is 6. That's all it tells us. That's all we know. But we should be able to calculate A, B, and C. Okay? So try that out.
Is the force constant K?
The force constant is K, yes.
It's the T, right?
Correct. Okay. So 1 over the frequency. Hopefully this one was pretty easy. So T is equal to 1/6. The decimal would be 0.16, so 0.2. Is that what you guys got? Using that equation? What's my angular frequency equation? 2 pi f. Okay? So 2 times pi times my frequency was 6. Pretty straightforward, right? And that answer should be 40 with 1 sig fig. How are we doing so far?
All right.
Feel all right? Okay, just a little practice. And then what's the mass? Okay, so now I know T, I know frequency, I know my omega, or not omega, I know my angular frequency. I know K. What equation am I going to use?
2 pi.
T equals 2 pi square root of n over 10.
You are exactly correct. You are exactly correct. That's what I'm talking about, you know?
I'm already learning.
I feel like today's going to be good, you know? So T, we said T was really 0.2, or if you just want to put 1 over 6. The 1/6 was T. K was
120. Change the problem, you goose.
How did that happen? Maybe I put my paper on it.
Maybe.
Oh,
What about you?
There we go. Holy smokes. Okay. So 1/6 divided by 2 pi. Divided by 2 pi. You're going to square whatever your answer is. And then times it by 120. That should equal your mass. All right, just rearranging all of it. So 1 divided by 6 divided by 2 pi. Square it times 120. Okay, so I got with one sig fig, I got 0.08.
For like grams or
Kilograms.
okay.
So 80 grams.
80? Yes.
How'd you guys feel on that?
Okay.
Decent on horizontal or one more? Questions. Love questions.
How do you know if it's gonna be, when you calculate it, how do you know if it's gonna be in grams or kilograms?
These are all in kilograms.
Well,
We're always using kilograms.
I know, but how do you know if you need to switch it over?
You
or
won't.
not?
You don't have to.
You don't have to, but I got 8.
You got 8 as your answer.
Yes.
Yeah.
You took. Did I plug it in wrong?
I don't know.
That's what I got. I got 8.224.
So one divided. So my time was 0.1666, right? Did you use that?
Mhm.
Okay. So did you divide it by 2 pi?
Mhm.
What did you get?
I think it might have accidentally divided by 2 and then multiplied it by pi.
Oh, I got, so after dividing this, I got 0.026.
Mhm.
That's what you got?
Mhm.
You squared it?
And I squared it.
And then I got 0.0007.
No, that is not what I got. I got 0.06.
Whoa. So we have 1 divided by 6,
It's so
right?
easy.
Then you divide it by,
Oh, yeah. You can do that.
Yeah, Jake, you don't have to.
I've been told about like 8
you got that,
Yeah.
square it,
Oh, so you want to put it
and
on.
then you times it by 120.
That's so weird that it did that.
That is weird.
The homework?
Because I did the same
No,
exact
I
thing.
got
I
it.
got the same
The
exact
first.
Just put it in
two
parentheses.
sections takes a minute, but after that, the
Oh, I
last
see.
one took me like half an hour.
Okay. Let's try one more. One more. One more. Question.
Is the W, or is for anywhere frequency, is it a W or omega?
It's
Big W.
it's a big W. It's a big W.
That sounds like something.
We do.
My baby cousin.
We do.
I think we need less.
Like the Hawaiian language.
Isn't that only like 13 letters?
Yes.
Yeah.
Oh, is
Okay.
this how you did in this one?
Let's try this one. Try this one out. Find out K.
Is this how you did it? You did, that and-
Correct. Yep. Yep. Okay, so let's see what we got here. Yeah.
That was a weird noise.
No, just reading it. There, it's makes you think a second.
Oh, yeah.
All Alright, so looking at these factors, I have 0.2 kilograms. That's a mass. I have a time, so I have a period, okay? What equation do you think I'm going to use to solve for K? What equation am I going to use?
F equals negative K times X.
Do I have F or X? No?
T
Okay.
equals 2 pi times the square root of mass over constant.
2 pi square root of the mass over K. So I have mass, I have K time. Okay, let's use that one. Okay. Now, the trick in this question is, did we read it carefully?
Yes. It made my brain hurt. So isn't the time
So-
just cut in half?
The time is half. So what it did was attach to an ideal negligible mass and start oscillating. The elapsed time from when the glider first moves through, let's say this is my equilibrium right here. When it first moved through and came back a second time, is that a full wave? No, that would be a full, right? So it only half of the time is 2.6. Does that make sense? The full time would be 5.2. Okay,
I was
so
about to say 4.1.
does that make sense, guys? And you just plug it in the equation again. Let's see. Mass was 0.2, and you solve for K. Okay? Oh, I got a little light in this marker. Okay? Divided by 2 pi. Square that value. And then eventually you're gonna have to. Okay, just rearranging the equation. And having one sig fig, did anybody get an answer? 0.3? Good? Okay, I was like, holy smokes. One person did it. 0.3. Okay. Oh, I guess. 0.3. How do we feel on horizontal?
I like horizontal.
Okay, let's skip to vertical then. So we're actually going to jump quite a few of these problems. All right, we're going to jump all the way to 16. Hot dog. We're going to skip a lot. I see what you did there. Good, 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 good. Okay, here we go. Skipping all the way to vertical.
Sorry for the interruption. Olivia Teeter, would you come to the attendance office, please?
Olivia.
Love Olivia.
You know Olivia? Wow. Had her last year.
She used to, and then she quit because she got a job at Bob Evans.
I work with her there for a few months.
She's pretty cool. I got in trouble because of her at the Salem.
Fair enough.
Y'all wanna know the story? It's pretty short.
Yes.
Yeah.
Okay,
Can I-
so she
can we-
came up to me and.
Yeah, we're already halfway in.
She came up to me and gave me her phone and said, record this. She put her head under the ice cream machine and pulled down the handle. And I got in trouble for it because I was recording. But I didn't know what she was gonna do.
She sounds smart.
Yeah. Interesting. Okay, so vertical. If the spring is hung vertically, the equilibrium position changes. The equilibrium position is at the point at which the spring force equals the gravitational force. So the spring force equals the gravitational force. That's kind of key, actually.
Is that what we should write down?
So the spring force will equal the gravitational force. The displacement is now measured from the new equilibrium. Okay.
Is that the equation?
Nope. Same equation. We know all the equations. Okay. So let's try a vertical out. Let's try a vertical out. Okay. So in this problem, a 2 kilogram block is attached to an upstretched spring of spring constant. Oh, I thought I did that. Spring of spring constant 200 Newton per meter, as shown in the diagram. If it is released from rest, determine the period of the block's oscillation. Too easy. Too easy. So determine the period. So I've got to find T. I have mass. I have K. This one is kind of straightforward, hopefully. What equation am I going to use that has M, K, and T?
T equals 2 pi squared.
Hopefully you guys are starting to get that one down. Right? So M is 2. K is 200.
$0.6.
0.6, is that right? Everybody got 0.6? That's vertical.
That's amazing.
Oh, look at this pink though. That's amazing.
Use that entire thing.
Oh, yeah.
All right.
I thought you were talking about that.
Everybody good to move on? Let's try another one. Ooh. Got a little bit bigger one.
Wait, isn't it? Oh, wait.
A 2 kilogram block is attached to an upstream constant of 200 Newton per meters, as shown in the diagram. What is the maximum displacement of the block? What is the maximum displacement? Okay, so we know this. We know 200 Newton meters, right? Know that. We're solving for X. On the previous problem, what did we just say our period was? 0.6 was our period. Just in case we need it. So we're solving for X. Solving for X. What equation do you think we're going to use?
Changing displacement equals 1/2 A times T squared? Question mark?
Okay, we don't know X. Do we know the amplitude?
Amplitude.
That's A. No? Yeah?
Wait,
Force of the spring?
isn't that?
I'm sorry, what? The full equation?
Oh, negative K times X.
So force is equal to negative K times X. Now, the question is, what was force? What was important? Force of the spring is equal to? Force of gravity.
Yeah. Oh, yeah.
Yo.
So instead of force, I can have mass times gravity. That's the key there. So force of spring is equal to force of gravity. And gravity is mass times gravity. Okay? So that should help us solve this. Okay? So mass is 2. Gravity is 9. Well, we'll do 9.8.
Oh, so I want to know if that would work.
Wouldn't 9.8 be negative?
It would, like, in theory, the displacement should have a direction. The direction's going to be down. But yeah, it should. So 19. Anybody get an answer here? 0.098 says 0.1.
Well, he just said that gravity was.
Okay.
Feels like a Friday. I don't like it.
Feels like a Friday?
Yeah, it does feel like.
It's pretty
What do you
close.
like about Fridays?
Because of knowing that I have school tomorrow.
All right. Let's. That's. I'm sorry. What?
I don't know why me.
So the unstretched spring
That's actually.
shown in the diagram. So originally it's a stretch. When you attach the block, the spring is going to come down. So we're calculating how far it is from its original position.
Okay, because that's where. Honestly,
All right, guys, let's try one more. I think we got one more in this.
Why go to?
You guys good with one more?
Why not?
And the best thing is multiple choice.
Oh.
Oh, yeah.
You had a little scream too. That's scary. That's really scary. I can bear with books falling.
All right, last one, guys. Last one. Okay. An object of mass 8 kilograms is attached to an ideal massless spring and allowed to hang. The spring stretches 3.6 centimeters. Just circling some factors I know. Before it reaches its equilibrium point. If this system is allowed to oscillate, what is the frequency?
What does oscillate mean? Bounce?
Bounce, bounce, bounce.
Sorry, that was really basic question. Why can't they just say I love bounce?
I have to use it. I've seen one.
Bounce. Mr. Bowers, I got my Invisalign off yesterday.
You got what?
My Invisalign?
Oh, that's cool.
Yeah.
Do you get
It was a
wait,
great
do
day.
you get out or in?
Huh?
What'd you say? Can you repeat that?
My Invisalign?
Yeah, no, like your first sentence you said.
I said, Mr. Bowers, I got my Invisalign off.
Oh, awesome. I don't know if I know what an Invisalign is.
It's like retainers, but they're like, they act like braces.
I gotcha.
So they like just pop around your teeth and you can take them out to eat,
Yeah,
drink, whatever you want to do.
that's pretty cool.
Yeah. And then you just pop them back in.
That's pretty cool.
And they shaved them down, so now they're like gritty on the bottom. And then top, I guess.
Yeah, that's cool though.
These are retainers.
You wore them during the day?
Okay, I haven't worn them in like 3 months. I got yelled at the other day.
How's everybody doing?
I'm gonna guess.
So I know I need frequency.
I got my answer.
What is it?
Okay.
A is the correct answer.
What equation did you?
Yes.
I used multiple.
Okay.
Did the
Easy money.
gravity times mass.
So we know, let's get some factors we know. We know force is equal to mass times gravity, correct?
Yeah.
So what's that equal? I think I have it written down.
Negative 70 something.
Okay. So we got F. All right. So F is equal to negative kx. So we know force is negative 78.4. We don't know what my k is, but we do know what x is. What's my x? 0.036. 0.036. Okay. Let's see. So what's that give me as k? 2,178. Okay, so I have a k value. I have my force. What equation am I going to use for frequency now?
2 pi square root m over k.
2t equals
Yes.
2 pi square root m over k. Can you guys see pink all right?
Yeah.
I've kind of been on a pink roll. It feels good in my hand. You know, it's solid. You know. So mass is 8. I just solved for k. K is 2,178. So that should give us our time, or our period, I should say. Anybody get a period? 0.38.
I might have done it wrong again.
Okay. But now we're solving for frequency, which we know frequency is 1 over time, or the period. So frequency is 1 over 0.38, which is hopefully A. How do we feel on that?
That's a lot of questions.
That